Yep, we are good to go. All right, everybody. I just wanted to say hello. Thank you for taking the time to stop by our training tonight. We're learning about a very, very cool product tonight. The RGF technology is quite fascinating. I think you'll all agree. Just so you all know, for the optimal viewing pleasure, I'm sure most of you already have, be sure to click the bottom 3 little dots for more options and then go to change layout and then go to spotlight so you can see the presentation with the full screen. Furthermore, if you have any questions, be sure to put them in the chat box on the right side. We will answer every question that is asked in there at some point. For technical questions, you're going to want to contact Jean-Francois. His contact information will be at the end of the presentation. For any pricing availability, you want to contact Doug Getz, whose contact information will also be at the end of the presentation. And lastly, the Remy Ion giveaway will be at the very end of the training, so stay tuned for that. We have about a quarter of the attendance we had last night because this is the second night, so it's a reasonable fall off. So your guys' odds of getting the Remy Ion are much higher than last night, so that's exciting for you guys. So without any further ado, sit back, relax, grab yourself a drink, and I will hand it over to Jean-Francois, who will give us some information. I will stop sharing my screen so you can go ahead.
All right. So can you confirm that we see my presentation properly?
Yep, all good.
Very good. So thank you very much, everybody, to be here tonight. My name is J.F. Barron. I'm from Spectral Air. Spectral Air is the representation agency for RGF in Canada. You have my contact information right there, but it's going to be at the end of the presentation as well, and at the end of the event presentation slide from Desco at the end of the event. We're going to talk today about products from RGF. RGF is a manufacturer based out of West Palm Beach, Florida. It's a private company. It's in business since 1985. They manufacture products for air sanitation, food sanitation, and water sanitation. They do mostly wash water recycling. Food sanitation, it's for food transformation plants. They do use the same technology that we're going to discuss today to sanitize food in transformation plants. This is the head office. As I said, it's located in West Palm Beach, Florida. It's about 100,000 square foot. During the pandemic, they bought another building of 40,000 square feet to do some vertical integration, meaning that they had a couple of subcontractors, third-party manufacturers that were manufacturing small parts for their devices, and a couple of COVID-19 outbreaks made these guys close for a couple of weeks, which slowed down everything. So RGF decided to vertically integrate everything. So now everything is built, assembled in-house. So they added a 40,000 square foot facility to the already existing 100,000 square foot facility. These are examples of different devices in water purification, in air purification, and food sanitation. These are all RGF products, and everything is manufactured in Florida. The manufacturing facility, the picture in the upper left, super clean, one of the most well-organized manufacturing facility I've seen in my career. I worked in lighting, in automation, in different industrial equipments. This is a fantastic place. Everything is designed, built in-house. The showroom as well is very impressive. They do have organized tour in the facility in Florida, and they're very much present in all the HVAC trade show in North America. They have a testing R&D lab and electronics R&D lab as well for their research and development. You're going to see a new product using LED modules that was developed in the last few years and was launched a bit more than a year ago, the Halo LED. We're going to discuss it a bit later. They do have as well results on tests that they conducted, but they do not publish the tests that they conduct. They have it. They have third parties, we're talking about universities and certified labs, to do the tests and publish the test results. So they have independent sources confirming that the technology is very effective, very efficient in destroying air pathogens such as microbes, gases, smokes, and airborne particles. RGF sells in China, and don't be mistaken, they do not manufacture in China. Everything's manufactured in Florida. In 2002 and 2003, when the SARS hit Asia, RGF sales really had a big burst in the Asian market. So they do have a sales office. They sell a lot of products in Asia. They also sell in Europe. They have about 5 million units working right now around the globe. And to give you an idea, in the last year, they had an increase in product demand of 1,000%. So the numbers of the year 2021 are going to be probably 10 times bigger than the numbers of 2019. A lot of awards, especially for their designs, a lot of patents as well. You need to know that the technology that we're going to discuss today, the PHI, which stands for photo hydro ionization. The PHI technology for RGF is proprietary. It's a unique technology. No other manufacturer on the planet has that technology. So it's a very unique active technology that sanitizes the full volume of air and all the surfaces in the treated environment. This is a list of different customers that RGF has. Of course, Spectral has been working with RGF for the last 3.5 years. Before that, there was a couple of sales here and there in Canada, but there was nothing really happening because nobody was promoting the products. But as I said earlier, RGF has been in business since 1985. So the technology we're going to discuss today has been sold for more than 20 years. And these are some of the big customers using the RGF technology. We're going to start with a summary of indoor air quality. It's really to expose to you the different pathogens that can be in the indoor air. How can we treat them? We're going to review some of the technologies available that you might know about to know how effective they can be, and most importantly, to know their limitations. So the existing technology have some serious limitations as of how good they can sanitize the air, and we're going to review that before we jump into the RGF technology, the photo hydro ionization, the PHI technology from RGF. So we have 3 different categories of pathogens that can be treated with different technologies. We have the microbes, the gases, and the particulates. The particulates in 3 different categories: the dust, minute solid particles less than 500 micrometers. Composition changes by season. The dander, material shed from the body of various animals, including humans. So you definitely have dander in your house, even though you don't have any pets. You have a lot more if you have pets. So this can be a cause of allergy. Pollen released by certain plant species, lightweight and small, they can stay in the air for a long period of time, and I'm sure some of you have some allergic reactions during certain periods of the year due to pollen floating in the air. Microbes, we have 3 categories. The bacteria, examples are E. coli, Staphylococcus, Streptococcus, so these are all bacteria. Viruses, of course, we all know about COVID-19, Norwalk, which is the common stomach flu, SARS, avian flu, H1N1, these are all viruses. Mold, that are initially spores. So the spores will develop into mold when we have a perfect mix of temperatures higher than 30 degrees Celsius and humidity higher than 60%. So the spores will develop into mold in different areas where the temperature and the humidity allow for it to develop into mold. I want you to pay attention to this graph. It's very, very important. It's very relevant of what we're living right now. These few next slides have been presented by RGF for the last 10, 15 years. In the last few months, the authorities, we're talking about Health Canada and CDC, the Center of Disease Control in the States. These are the 2 highest authorities, health authorities in North America, and they've been going back and forth as if the virus was contagious by air. So was it contagious by aerosol? Was it airborne? So now they're unanimous that the virus can be airborne. The virus can be traveling a lot more than that 2-meter social distancing. And the 3 illustrations that we have here show clearly why. We have at the left the large infectious droplets. So this would be spit or drops of sweat. And these format of infectious droplets, the larger format, the most humidified one, will not travel very far. We're talking about 1 to 3 feet. The small infectious droplets, it's pretty much the same, but dehumidified. So it's much lighter and it will travel further distance. We're talking about 3-5 feet. So considering the small infectious droplet, the 2-meter social distancing makes sense. But if we go to the right, we have the infectious droplet nuclei. So this is the most dehumidified form of the infectious nuclei. And still it is active and it is very much contagious. So this form of infectious nuclei is very light and airborne. So here we can see that the large ones will fall 1-3 feet. The small ones, slightly dehumidified, will travel 3 to 5 feet. But the infectious droplet nuclei at its most dehumidified form can travel up to 160 feet. So in a room where we have an infected individual coughing or breathing, the infectious droplet nuclei can travel much further than 2 meters. So it is very important for everybody to understand that the contagion risks are 20 times higher indoor than outdoor. So having an individual that is infected, coughing or breathing, throwing some infectious droplet nuclei in the same room, if you don't have your mask, or if it falls in your eye or in your ear or on your hands and you scratch your nose a bit later, it's not the majority of the infections, but still this is one of the probability of being infected. So these infectious droplet nuclei can travel much further than 2 meters from one individual to the other, but they can also get back in the HVAC system and travel in the ducting. So it's very important to know that this information has been promoted by RGF for a long time, and now this is actually endorsed and communicated by the highest authorities, which are Health Canada and the Center of Disease Control in the US. Another pathogen, the gases, the VOCs, volatile organic compounds. If you walk into a new house, you're going to smell the paint, the varnish, the glue, the adhesives, carpets, cleaning agents, also nail polish, the presswood products because of the glue. So the VOCs can cause eyes, nose, and throat irritation, headaches, of course, in extreme cases, loss of coordination, nausea. Another gas type category are the odors, pet odors, perfumes, food odors. So we have the microbes, we have the particulates, and we have the gases that can be pathogens, bad for occupants in indoor air. So how can we treat these pathogens? So the different treatments technology for microbial and gases, we're going to start by the oldest one, very well known by everybody, the germicidal ultraviolet light. So germicidal ultraviolet light was discovered in the 1950s. So it's a technology that was discovered 70 years ago. It's very efficient, it's proven, but it has some serious limitations. So the germicidal UV light is a set fixed wavelength of 254 nanometer. So most UV lights that we're going to see on the market are fluorescent lights. And these fluorescent lights will have a specific coating inside the tube. It's composed of different phosphor powders, and it lets that specific 254 nanometer spectrum out. So that's the only light that will come out of the only radiation that will come out of that fluorescent tube. So ultraviolet germicidal light are effective. It destroys the DNA. But in order to destroy the DNA of an organism, such as microbe or virus, bacteria, or mold, it needs to be powerful enough. What we mean by that, the power of the lamp is important, and the time of exposure is important as well. So the closer you are to the lamp, the better it is. But the further you get away from that lamp, it becomes exponentially inefficient. So it's the inverse square law. So as further you get from that source, that UV source, it becomes exponentially inefficient. So to achieve the proper kill dose of UV germicidal radiation, you need a sufficient UV lamp power, and you need it to be exposed to the pathogens for long enough. So it's going to give you the kill dosage. Think of a candle like germicidal UV. If your hand is a foot from the candle, you don't feel anything. If it's 3 inches from the candle, you're gonna feel the heat. It's not gonna burn, but you're still gonna feel the heat. If it's 1 inch from the candle, of course it's gonna burn, but it's gonna burn you seriously if you stay there for a long period of time. So that's pretty much the same with germicidal UV radiation, germicidal lamps. It needs to be close enough to the source for long enough. On this graph, you see that UV germicidal lamps or passive air purification. We have an example here of a system that is 1600 CFM that is going through a 16-inch by 16-inch duct, and it moves at 900 feet per minute. That's about 16 kilometers per hour, 10 miles per hour. So it's a 36-watt UV lamp. So it's a fluorescent 36-watt UV germicidal lamp. To show you how big it is, a 36-watt fluorescent lamp is about 3 foot. So it's a 3-foot lamp. And on the first line, we see the distance. So we're considering the distance that the air and the pathogens are passing from the lamp. So at 1.5 inch, we have an effectiveness of about 100%. And this is because the minimum required sterilization time, so the time that the pathogen needs to stay exposed to the lamp, to that 36-watt lamp, is 0.18 seconds. So it flies by pretty quickly in that 1600 CFM system, and the microbe travel time is 0.16 seconds. So it's slightly faster, but we're going to round it up to make sure that we're objective, and we have an effectiveness of 100%. So whatever pathogen passes by at 1.5 inch from that 36-watt lamp or less, it can, of course, be in contact with the lamp or be in between 1.5 inch and directly to the lamp. So everything that passes in that zone is going to be sanitized. But if we go to the second line at 3 inches, so we go from 1.5 to 3 inches, but the effectiveness goes from 100% to 25%. So this is a good illustration of the inverse square law. So the minimum required sterilization time is half a second, but the microbe travel time is a third of a second. So the travel time of the microbe is too fast. The UV radiation doesn't have time to do its full effect, and we only have 25% effectiveness on the pathogens that are flying by at 3 inches from that 36-watt UV lamp. And we look at the 6 inches, it's even less. We get from 25% to 6.25%, because the minimum time would be 2 seconds, and it's only flying by for 2/3 of a second. And for 12 inches from that 36-watt UV lamp, the effectiveness is only 1.66%. So imagine that the duct is 16 by 16. You have a very large proportion, a very large portion of the air flying by that will have absolutely no effectiveness or very little effectiveness of sterilization, because everything that goes by at 1.5 inch or less is going to be sterilized, but everything over that is going to have very little results. So we can see the limitation of UV germicidal lamps in air purification. But don't get me wrong, there's some applications where UV germicidal lamp are very effective. If you see here, a coil with a UV stick lamp is very effective because we have continuous radiation, and when the sticks are disposed, you have sufficient amount of UV lights on your coil, you're going to be able to keep it clean because you're going to have enough UV power for long enough continuous radiation on the coil, so it's going to keep it clean. So as you can see on this picture, everything around that lamp is super clean, but as you get further at the right, you see that the mold has developed because UV does not travel. It's like the candle. If your hand's at 2 feet from the candle, it's not going to burn, you're not going to feel any heat. So it's the same with the germicidal ultraviolet light. So in order to keep your coil clean, you do a good installation, you have enough lamps that will shine properly at the right distance, and in continuous radiation, your coil is going to stay clean. But you need to make sure that you have enough UV lamps on that coil so it stays clean. For your information, RGF is manufacturing these UV sticks to install on the coil because this is the perfect application for germicidal UV lamps. For air purification, it is very, very limited the action on the air passing by is just going to be a small fraction of the full volume of air flying by that germicidal UV lamp. And it has absolutely no impact on the air in the environment and on the surfaces in the environment. Another technology, another passive air purification technology, is PCO technology. So PCO stands for photocatalytic oxidizer. So what it does, photocatalytic oxidation reactor, it uses UV light striking the catalytic bed. So if we look at the picture from the previous slide, we have that white enclosure on the device on the right with the yellow sticker. So in there, you're going to have the power supply for the UV lamp. The UV lamp is going to stick out in that rectangular square tube, perforated tube on the other side. This will be inside the ducting at the return of the system. So inside of that tube, there's the UV lamp and there's titanium oxide plate. So we have a reaction that takes place on the surface of the catalytic bed. So it's an oxidation reaction. It's going to create hydroxide and ozone, and these oxidizers will destroy the DNA of all microbes. The higher the surface area and the more UV energy that reaches it, the more efficient. So in order to have something that would be very efficient, and same goes for the UV germicidal lamps, we would need to have a wall inside the plenum. So it would pretty much block the airflow. We would make sure that all the pathogens are going through cylinders of PCOs, and it would have a very much maximized sanitation action. But it would have definitely a super high cost, and it would definitely impact the airflow of the system. So the PCO is effective in the surface, in the volume of air of that tube, but outside of it, there's no oxidizers. So everything that goes through that tube is going to be treated, but under, over, and on the side, all the pathogens will just keep on flying in the system. Think of a bug zapper. You can have flies spinning around it all weekend. If they don't go inside, nothing's going to happen. So it's really within that cylinder that the sanitation action is happening. Everything around it, there's no action whatsoever. Now we're going to talk about photohydroionization. So remember the PHI technology from RGF. So PHI, photohydroionization, is the creation of hydroperoxide from a reaction that takes place between UV light. So PHI technology is using UV light as well, but in a broad spectrum. So it takes place between the UV light, the air, specifically more the oxygen, O2, and water, H2O, and the quad metal catalyst. These hydroperoxide are friendly oxidizers or very effective in breaking down both airborne and surface-borne microbes. So when we say airborne and surface-borne microbes, the hydroperoxides are stable enough to go in the entire volume of air and sanitize every cubic inch of air and every square inch of surface. So the device from RGF are installed in the feeding plenum. And if you read correctly, you will see that the UV light, the air, and the quad metal catalyst are generating hydroperoxide. So the UV light is not used as a germicidal action. The UV light is used to generate an advanced oxidation process with the air and the quad metal catalyst. So we have stable enough molecules of hydroperoxide in its gaseous form, and the hydroperoxide goes in the full volume of air and on all surfaces. On the last line, the high humidity of most food plants benefit these reactions. So what we mean by that is, as I said a bit earlier, the product is installed in the feeding plenum. Often we have the humidifier close to it. So we have a lot of installers asking, is this a problem? Actually, no, it's actually a benefit, because if you have a higher humidity in the air, you can have a better advanced oxidation process, because the UV light, the air, or specifically oxygen and humidity, and the quad metal catalyst all interact together to generate the hydroperoxide ions. This is a picture of the PHI, photohydroionization. So the PHI cell, in the center you have the lamp. It's the broad spectrum lamp, which uses a spectrum between 100 and 380 nanometers. So The UV germicidal lamp is categorized in the UVC. So you have different brackets of UV light that are composing the UVA, UVB, and UVC. So the germicidal action is within the UVC. Here we have a broad spectrum lamp, which is between 100 and 380 nanometers. So this covers UVA, UVB, and UVC. So we're not trying here to compete or to compare to UV germicidal lamp, because this is not at all the same action that we're using UV rays in this technology. We're using the UV radiation to generate an advanced oxidation process. So it's not the UV light that will sanitize the environment, it is the hydroperoxide ions that are pushed in the entire volume of air and on all surfaces. Around that lamp, you see that perforated grid. This is the quad metallic hydrophilic coating. So that quad metal has titanium, rhodium, copper, and silver. So this composition of metal, the broad spectrum lamp, with the interaction of the water and oxygen in the air, creates the advanced oxidation process. Here we have the location of the spectrum used in the RGF technology. It's between tanning rays and medical X-rays. So we have all the different waves, spectrums of radio waves, microwaves, infrared, visible light rays, UV rays, and X-rays. So we're at the far end of the UV ray spectrum. It's a transversal cut of the PHI cell, the lamp in the middle, the PPC sleeve. This is a shatter shield. So if ever it's dropped, there's an impact, the lamp is not going to shatter in 1,000 pieces. It's going to stay all in the same one piece. This is the broad spectrum lamp. It is, as I said, between 100 and 380 nanometer. It's pretty much the same. The only application where that type of spectrum is going to be used. So RGF has a proprietary technology. They're the one that invented the PHI technology, and these lamps are very unique to RGF. So here we have the different metals used in the catalytic bed: rhodium, titanium, silver, and copper. So here we have the reaction happening with the catalytic grid. The important thing to remember is that the catalytic grid is not wearing out or decomposing. The metals that are on that grid around the lamp are just going to stay there. They're going to stay the same. They do not change the composition of the air because it's H2O, the water vapor, and O to the oxygen that will convert in the advanced oxidation process in H2O2, which is hydroperoxide. So the hydroperoxide ions are active for 15 minutes, about 15 minutes in the environment. If they do not run across a pathogen, they're just going to revert back to oxygen and humidity. So H2O2 is going to go back to O2 and H2O. And if they get in front of a pathogen, they attack it, destroy it, and they revert back to oxygen and humidity. So it does not change the composition of the air. So why is the PHI technology so unique? By utilizing a broad spectrum lamp combined with PHI target, which is the grid of titanium, rhodium, copper, and silver, we not only produce conventional AOP, advanced oxidation process reactions, on the cell surface, we also produce advanced oxidation process reactions within the air that passes through the cell. Hence, the hydroperoxide ions that are freed, that are pushed in the entire volume of air, and they kill the pathogens on the surfaces as well. RGF, as I mentioned in the beginning, is very, very keen on testing everything. So they did a sneeze machine. So it's a very interesting invention. They're going to take some fluid loaded with microbes and shoot them out at the speed of a human sneeze, about 100 miles per hour. It was proven by independent tests that all the viral charge in that fluid pushed out as a sneeze was immediately reduced by 99% within 3 feet of the outlet of that sneeze machine. Here we have the test booklet. So it's tests that were conducted between 2000 and 2016. If you look at the first one, it's H1N1. So H1N1 flu virus, or swine flu, is in the coronavirus family. So it was tested in 2009 and 2010, and it proved that RGF technology, the PHI technology, kills H1N1 on surfaces and in the air up to 99%. So, important thing to know, there's a lot of products out there that will claim that their technology eliminates viruses in the air. The thing is, you always need to know what's in the fine prints. So we have competitors that will do some tests in very tiny biochambers. I'm talking about something as big as a microwave or even a shoebox. Any electronic that you turn on in such a small volume of air would generate some ozone. And that concentration of ozone would destroy any pathogen, virus, microbe, bacteria, mold in that small volume of air. On the other hand, RGF is testing in real life environment. So the biochamber in which they completed the test is over 1,200 cubic feet. And the tests were conducted with the viral charge on stainless steel. There's a lot of manufacturers that will claim that their device kills all the viruses in a very short period of time, but some of them are doing tests with their viral charge on aluminum. Aluminum doesn't allow viruses to survive very long. So there's even manufacturers that will do aluminum surfaces to avoid a long lifetime for the viruses. So it's important for you guys to know about that. If ever you run across some test results from competition, you can ask them some questions about the protocol, because often it's either that they're using a tiny biochamber or the surfaces on which the viral charge was put doesn't allow the viruses to survive very long anyways. So why advanced oxidation of air? Why is the PHI technology so much better than all the other technologies out there to reduce the risks of contagion? Well, it destroys airborne contaminants, including mold, yeast, bacteria, and viruses. It kills COVID-19 in the air and on surfaces. It reduces surfaces contamination because these hydroperoxide ions are sanitizing the full volume of air in all surfaces, and it reduces cross-contamination because it's an active technology in the full volume of the environment. We're going to look at a couple of products. The Halo LED. So as you can see, the shape is very different. All the other PHI cells are using fluorescent lamp as the UV source. This one here was launched at the beginning of 2020. It is using an LED module array for the UV source. So big advantage, the lifespan. Instead of being 25,000 hours like a fluorescent lamp, it's going to be between 17 and 90,000 hours. So the lifespan of this device is 3-4 times longer than the lifespan of a PHI device with a fluorescent lamp. So don't mistake our fluorescent technology is the same than everybody else. So all UV lamps will last. Fluorescent UV lamps will last between 1.5 to 2.5 years. So that's the maximum that you can get out of a fluorescent UV lamp. All manufacturers together, it's always the same technology of fluorescent lamps. So this one here has a warranty of 7 years on the power supply and 4 years on the LED modules. So it's also certified zero ozone. So all fluorescent lamps for UV germicidal applications will emit ozone. So any fluorescent lamp for UV germicidal application, they will emit ozone, but they're within 0.05 ppm of ozone maximum. So this is the standard for North America, for Canada and the States. This device here, the Halo LED, is certified zero ozone. So instead of having a maximum of 0.05 ppm of ozone, it is below 0.005 ppm of ozone. So it produces pretty much no ozone and is going to be a lot more effective in producing hydroperoxide. At the left, you can see that black cap at the left end. This is a bipolar ionizer. So it has an integrated bipolar ionizer on it. The Halo LED is suited for systems between 250 and 6,500 CFMs. It can also be installed in multiples. For example, if you have a 12,000 CFM system, you could install 2 devices like this in the feeding plenum to generate enough ppm of oxidizers. the REMI Halo. So this one is using the PHI technology with fluorescent lamp. It's going to be good for systems between 1,000 and 6,500 CFM. Very good product as well. Its maintenance is a bit more frequent because of the fluorescent lamp, which has a 25,000 hour lifespan. So you would need to change the cell every 2.5 years. Very simple. You don't really need any tool. It's all quick connect. You disconnect the lamp inside and you connect the new one with the cell, and that's it. The REMI Ion, this is a tabletop device, slightly bigger than a can of pop. It uses LED technology as well. So you can have that square plate with the LED modules that creates the, that generates the hydrogen peroxide with the advanced oxidation process. It also has a bipolar ionizer integrated. It has a very quiet fan, very nice design. That white button is just a touch button, very, very effective. Very quiet. It covers up to 200 square foot, and also you have as an accessory a USB cable. This works on 12 volts, so you could actually plug this into a car when buying the 12 volt USB cable. The Halo Rove, that device that product is fantastic for areas where you don't have HVAC systems. So it is available in 120 volt and 12 volts. So the 12 volt version is going to be good for transits. We're talking about school buses, coach buses, trams, metro wagons. It can be attached to the wall or just on the desktop. It's a very solid stainless steel enclosure. You have the PHI cell inside. The fan is 75 CFM, and you have the outlets on the sides where the hydrogen peroxide is freed in the environment. So as I said, it's available in 12 and 120 volts, and it covers up to 1,000 square feet. The PIP Max, that device goes directly over an electrical outlet, so a regular double electrical outlet on the wall. You don't lose the outlet, as you can see on the box on the side of that enclosure. You still have the outlet on the side. Also, that device has an integrated bipolar ionizer. So the PIP Max covers up to 800 square foot, and it's a 2-year warranty on that device because it's using fluorescent technology. The Garden Air, you can recognize the PHI cell. It's a longer cell, it's a longer lamp. It's going to generate some more hydrogen peroxide. It's good for systems between 10,000 to 18,000 CFMs. The mini split unit, so you can see that strip on the top of the mini split head. The PHI cell is going to be in the center of that, and there's some baffle directing the air towards the cell that goes inside the head and that are pushed outside with the fan of the mini split head. So 2 major benefits. Of course, you're pushing some hydrogen peroxide in your full volume of air in the environment and sanitizing the surfaces as well. That's number 1, very important. But you have the oxidizers passing through the head, so there's a lot of mold developing in the mini split heads. So you're pretty much canceling the maintenance. When you have that mini split PHI unit, it's going to keep your mini split head clean, and you're not going to need to clean it once in a while because the molds, with all these oxidizers going through it, the mold is never going to be able to develop. It's good for systems between 250 and 2,000 CFM. One more thing, it's available in 110 and 220, depending on the voltage of your mini split head, and it's installed either on the side or at the back of the head. You can have a knockoff, you just connect it in the breaker inside the head. The package unit, this is a different model. The enclosure has the power pack included inside because that unit is going entirely in the plenum. It's going to be either installed on top of the air handler or on the walls of the ducting. There's 3 different models, and you have the PKG5, PKG9, and PKG14 with different brackets of CFMs. It's very easy to install because it has magnetic feet on it. So you see these square feet on the corners. So you just stick it to the top of the air handler or on the ducting and connect it to 24 volts. So you know all the induct devices from RGF are working on 24 volts. This is the CML, commercial PHI air system. So CML is for big systems, for larger rooftops. It's available for systems between 25 to 250 tons. It can be installed inside or outside. If you install it outside, you're going to need a NEMA enclosure over the electronic enclosure. Here we have a typical installation of the Gardner Remy installation, Halo LED. It's in the plenum. So we want to have that maximized pressure of filtered treated air, humidified air going through the PHI cell, generating the hydroperoxide ions, and these hydroperoxide ions are then pushed in the entire volume of air through the ducting. So it sanitizes the air in the ducting, the surface of the ducting, and then it goes outside in the full volume of air and sanitizes as well all the surfaces. The Boss Hawks, this is a very unique product. It has a very, very unique application. It's for garbage rooms. So it produces a much higher ppm of oxidizers. It's for unoccupied environments. It's very, very efficient. You can have it directly on the floor, or you can connect it at the outlet. You can plug in a hose, and that hose, the other tip of the hose, would be inside the container. So the oxidizers are going straight into the container to eliminate the odors inside the container. So a lot of customers have installed these, and they were able to cut down the air conditioning because they no longer need to cool down the room, since the Boss Hawks has been eliminating all the odors. So that's pretty much it for the crash presentation on the PHI technology. So it's 7:40.